All right, good afternoon, Somerville High School pre-calculus students. A little bit more on geometric interpretation of absolute value signs and a little bit about transformation of those absolute value signs. It's a bit of a review. Some of these things we've seen before, but I want to take a look at it more in a graphical representation of what's going on. Um, Oh, back from the last video that we were talking about, there's one point I wanted to make, which was notice that for f of x is equal to the absolute value of x, that the reason that we can see that the absolute value could never equal a negative number from a visual standpoint is let's say that there was some graph of a horizontal line like h of x is equal to negative 2. Clearly, the f of x absolute value does not intersect with h of x. We can see that. So there's no way that the absolute value of x could ever equal negative 2. Just wanted to cover up that point I didn't make in the last video. Okay. A little bit about transformations. So if we call f of x the parent function, and g of x is a transformation of the parent function f of x, we see this minus 4 right there. And that minus 4 is taking f of x and moving it to the right 4 spaces. And there is the new vertex for g of x. It's right there, 4 comma 0. Now our intuitions, or some of our intuitions, would tell us that it seems like when I see a minus sign that the transformation would go to the left horizontally instead of to the right horizontally. Let's just take a look at why that's not true. So let's say that g of, if we plugged in an input value of 4 into the g of x function, and then that means that we get 4 minus 4, and then the output is 0, and that would mean that the input was 4, the output is 0, and indeed there is that vertex 4 comma 0, and it's been transformed horizontally 4 to the right and not 4 to the left. Okay, so just a little bit on that. Next question that seems like something that maybe we want to take a look at is what happens if there's some function called h of x and it's equal to 2, and I want to know where this h of x intersects with the g of x function. So once again, let's take those functions and set them equal to each other. So the question I'm asking is, when, for which values of x, does g of x equal h of x? Well, we can see visually that it's hitting right there at 6 comma 2, and it also has another intersection point right there at 2 comma 2. Well, let's prove that algebraically. So let's let 2 equal the absolute value of x minus 4. Alright, so there's two solutions. X minus 4 equals 2, or the opposite of x minus 4 is equal to 2. Over here, x is equal to 6. Over here, doing a little distribution, negative x plus 4 is equal to 2. Negative x is equal to negative 2. Therefore, x is equal to 2. And we can see that our intersection points are right where we saw them visually. There's my 6 right there, and there's my 2 right there. And their intersection points are 6, 2, 2, 2, and of course that 2 is that guy there and that guy there. Okay, there we go.